All right, we're live on YouTube. We'll be dropping the link on the chat group so you could share with your network for more participants. So greatly, we had a very nice overview yesterday and had an interactive session with the builders yesterday. Uh, this event is made possible with the collaboration of the Web3 Unilag ecosystem in the University of Lagos and some other great communities in Port Harcourt, based Benin, based Anambra, based Lagos, based Abuja, based Kaduna. So a lot of communities are part of this hackathon, and the Onchain Summer Buildathon is an initiative from the base. Is another way of onboarding the next billion users, the next billion creators on the ecosystem. And as a community, Ethereum Nigeria, as a matter of fact, my name is Chukwemeka Inokunbebe, so I lead the Ethereum Nigeria. We have been, building, organizing meetups, workshops in the beginning of the year. And then we're happy to also be part of this initiatives. And then we're actually giving everyone an opportunity to, contribute. So we have like close to like 200 ETH at stake, 20 ETH on each track. So we have like 8 track. And then each track consists of 20 ETH. So we have 2 to 10 winners per track. And as a community, we want to intentionally participate and then also look beyond participation. We want to see how business can start up from these initiatives. Then there's an opportunity for all communities to get involved. So if you know any person who is doing great in the ecosystem, just direct him to join us. From next tomorrow, we'll be having the in-person meetup, the IRL meetup in different locations. So we'll give you more information on that. I want to thank you guys for tuning in. I don't know if someone wants to express, maybe share some of what you've learned yesterday or what you're already doing before we introduce the speaker. You signify, and then we'll give you the mic. Yeah, so we want to know if your experiences so far. Today we hope to like build different teams and then start engaging on the group. So attach about 4 mentors on this to see that you guys succeed. So if you have anything to share, you have the option. But if not, we have our speaker who is here and ready to go in the next 1 minute. All right, so do us a favor by sharing this event to your community. Let's fill the house. Have a nice day. It is a pleasure to have you, and then let's build. The builders are hungry and ready to be inspired by what you'll be sharing. So you have the mic.
All right. Sorry, just to confirm, am I audible?
Yes, you're fine here.
Yeah, thank you very much. And also thank you for having me. Hi everyone. So let me just quickly share my screen so that we can get started immediately. 1 second. Trying to share the entire screen. Just give me, let me share. Okay, yeah. Share. Can you all see my screen? Maybe on the chat or like somebody on mute and then yeah. Can you confirm you can see my screen?
Yes, we can see your screen.
Yes, we can.
All right. Thank you. Thank you once again. Thank you all for joining today's session. Enoch mentioned, like we're really excited to see everything you guys are building and also how you have been participating so far in the Onchain Summer Hackathon. And also, like you mentioned, like this is a great opportunity for you to explore new things and for you to continue building, because the goal is not just for you to build something within this hackathon period, but then also think beyond the hackathon, think something you can build that a lot of people will benefit from, and also something very useful that at the end of the day, after the hackathon, you can ship it as a full-fledged project. So today we'll be talking about Farcaster Frame, which is one of the options that we have as part of the bounty, like Enoch mentioned. But then I want to like go through, if you're hearing Farcaster for the first time, don't worry, I'm going to explain everything about Farcaster during the session. And I'm also going to tell you how everything started, where we are at the moment, and also some of the things that you can do with Farcaster. So let's get right into it. So the topic we'll be going through today is building a Farcaster frame like a pro, everything you need to know. So, bio, a brief background about me. My name is Idris Olubisi. I am a software engineer and a technical writer. I currently work as a developer advocate at Interrupts Lab, working on Axela. And you can find me on all social at Olanesoft. Yeah, let's get into it. So what we'll be covering in this workshop is we'll talk about the Open Graph Protocol, Farcaster frames. We'll also take a look at some of the tools and starter kits that you can utilize to quickly build your frames. And then I'll be using an example. I'll also talk about the Axela GMP, which is an example of what we were able to build with that particular frame to do multi-chain interaction. So you'll be able to deploy your frame, interact with a particular network, and also send interaction between different chains within the same frame, right? And then we have the demo session that we are all going to go through together. Yeah. So let's talk about Open Graph Protocol. So, but before I get into what Open Graph Protocol is, I just quickly want to take a step back and then share a story around what social media looks like today, right? In the recent year, there have been increased use of social media by individuals, professionals, and various other groups, and they have demonstrated like this rapid evolution with this platform. So this particular trend emphasizes on how social media is increasingly used to influence, connect, and also transform the global communication and interaction like we have today. But then having all of these social media application, different application, imagine you having a social media platform that instead of just posting a static content, maybe you upload an image and then people can just like the image, comment under the image. What if you have something that looks like an image frame, but then you can interact with it, right? Which means that it's not just a static content, but it's something that you can interact with as a user on your social media app. So this is exactly the vision for frames. And these allow you to embed mini application directly into your posts or your tweets or your cast or whatever it's called, depending on the social media app, and then turning them into things like, games, things like live feed, things like polls, among others. But the interesting thing is that the inspiration of this whole idea came from a very old technology, which is known as the Open Graph Protocol, right? But then it was repurposed to fit the new decentralization that we currently have. So the journey of Farcaster frame is very simple, and it is to make social interaction more engaging, interactive, right? And also allowing developer to build amazing app, leveraging the Farcaster frame, and also allowing users to interact with whatever frame they've built. So we've seen in the past where you see frames like that allow you to mint NFT, frames for playing games and then get reward directly, and all of those things, right? Today, Farcaster frames represents that main deal that allow you to dynamically interact with different things on your social feed, right? So what exactly is Open Graph, which is the old technology I mentioned? Open Graph, sorry, I'm kind of hearing like the background. I don't know who that is. Can you please mute your mic? All right, thank you very much. So, the Open Graph technology was originally introduced by Facebook in 2010. And what Open Graph does is to allow web page to become like rich objects in a social graph by defining a particular structure and a metadata. So Open Graph basically enables social media platform to display enhanced preview and also shared content, which includes like things like title, image description, and improving engagement visibility. So I know a lot of you might have seen maybe when you upload a particular link on X today, you see a social card that is generated for you. And then it contains like other information like the link, the title of that particular post and all of that. So some of these things might not be visible like on the client side, but then ideally that particular image comes as a specific metadata and a way of previewing that image whenever you make a post on the URL or like a URL or as a post on any of the social media application, right? But then let me show you what exactly how those metadata looks like. You might already be familiar with this if you're already into like building application and then also trying to implement search engine optimization into your application, because it's pretty similar where you set like metadata for each of your pages, or like you dynamically create an SEO page and then pass it in across your application in the layout. That way you can dynamically set metadata. So, but then this is what a typical Open Graph meta tags in HTML looks like, where you have the meta, the property, the meta contains like things like the property. Yeah, you can specify the content of the property. You can also specify the type, which type of metadata is this. In this case, we are referencing like video.movie. You can also select the property of URL. You can select the property of image. So the interesting thing is that you have like, title, type, depending on what exactly you want to set for the particular, meta tag. And this is typically what Farcaster frame extended today. So this is what you can do. But with all of these things, we have, they are all static content, right? Especially if you had image, it's just an image. You cannot interact with the image. They are just there. So because they allow you to inscribe, meta tags in your HTML, it makes it easier for you to be able to set an OG URL types, title, and also do some of these, SEO preview, like where you preview like a SEO card on the social media platform. All of these things are something that you could easily do with just setting meta tags. And then let's talk about Farcaster frame now that you understand what open graphs are and also how they look like in HTML today. So what exactly is Farcaster frame? Or let me say, what exactly is a Farcaster frame? Farcaster frame generally is a set of meta tag that is returned within the head of an HTML, which is similar to what I showed you just now with Open Graph, right? But then the only thing is that it extended what Open Graph currently does and then allow you to dynamically inscribe or like add more functionality into your meta tags. because frames particularly are standards for creating interactive and authenticated experience on Farcaster and embeddable in any Farcaster client. So that way you can embed all of these meta tags that are dynamically created by frames into your application and then render them on any of the supported Farcaster clients. Today we have Webcast, we have Supercast, we have Yop, and then we have Canvas, we have Launchcaster. So there are a lot of them anyways, but I think the most popular one is Webcast that you might have seen before now, which is just serving as a client to where you could interact directly with the frame that is being built by anybody anywhere. So this is what the example of a frame example in HTML looks like. You can see that in this example we have something similar to what I showed you guys on the Open Graph example in HTML. But now the only difference here that you might have already noticed is that this comes with a tag called FCFC, which is missing from the one I showed you earlier on. And this is to tell that, yeah, this is the Farcaster frame. And this is typically just extending what Open Graph protocol looks like right now. And the fun part is that you can even mix properties, right? Because you are using the Farcaster frame does not mean that you can't use the default Open Graph, and which means that you can set different properties. But the interesting part now is, apart from setting images, URL, and title and all of that, you can also set a button, which is something that does not exist before now without Farcaster frame. So now Farcaster frame allows you to set a button. So you can have button 1, button 2, button 3. You can set the action type for a particular button. You can customize it the way you want it. You can create a backend for it in such a way that whenever that button is clicked on, it calls a particular function. Don't worry, I will show you everything what it looks like during the demo. So you see what the code looks like, and also an opportunity to go through this together. So I have this example that I got from the Farcaster documentation that shows you a typical example of a Farcaster frame where you have like a frame for quiz, and then it allows anyone that is currently interacting, like that find this particular frame on their timeline, to get started by playing a game. And then in the beginning, this is what they see. When they click get started, it takes them to another frame. And then another frame asks them the question, the quiz question, and also give them option to select. You can see based on what I mentioned earlier that we have like buttons. So you can customize this button to redirect to create a post action or a transaction action, a link or whatever, to redirect to this particular screen whenever a user clicks on this. So if you click on bar, then it means that yes, you've won this game, and then you can click on something else to claim your prize. In fact, if it's all, you can also decide to build, if you're the developer that is building this particular game, you can also embed claiming prize within the frame without having to leave the entire client completely. But if you select this, it's going to show this screen and it's going to ask you to play again, and then it redirects back to I think it redirects back to the home page where you can restart the entire game. So this is the simple flow. This is how you can build a frame that allow you to interact with it directly. And instead of having the static image type, you don't have that static image. You now have buttons, you now have options to customize in the backend. So these are typical example of what like Farcaster frames look like. This is an example of a frame talking about AVS microservice, micro hacks, hackathon, and then getting people to like read more. You can see the button here, they can sign up directly. This is another one where DC was talking about, participating in the Onchain summer, and then you can nominate a friend, you can mint NFT, just like what I mentioned earlier on. You can view the collection. You can see like we have like this logo that shows that, yeah, this is going outside. This is an external URL. And then we have like the speedrun experience. This is another example where you can click on start and then you start something depending on what was customized in this particular frame. And then finally, we have this particular one here that I created that we're going to go through together during the demo session. So how does Farcaster frame work? Now that you know like the definition and also what Open Graph is, and then now definitions, but exactly let's look into how it works under the hood. So this is a very simple flow of how this particular Farcaster frame architectures are. First, we have the Farcaster app, which is the client. In this example, we are using Webcast. And then we have the Farcaster hub, which is the Hubble. The Hubble. We are using Hubble as an example here, right? And then in between, we have the frame server. So basically, the frame definition itself is where the user interacts with, right? That's where the UI is going to render on the application. But then that frame now interacts with a frame server that can now send data directly from that frame server to any hub. So in case you have like any other layer that you're interacting with outside the server, you can do that on the back end and then return the result back to the Webcast client, right? But then it's important to know that the frame server just handles the action that is received directly from the application, that's from the client, and then can consult like a Farcaster hub for validation or additional Farcaster data. So this is how a typical flow looks like if you think about how Farcaster frames works under the hood. Not something complex, it's very simple and straightforward. You just have to customize things based on what you want to do and how you want to do it. So, but then what exactly, like building like a pro, right? You can typically just start building Farcaster frame with meta tags and all of that. But how exactly do you build like a pro and also save time during the process of thinking through like end to end? Just channel that energy to think about the logic other than trying to, figure out how you are going to arrange your frame meta tags, how you are going to simplify the process. So we have like starter kit and tools for building frames that can help you build your Farcaster frame like a pro. The first example here is frame.js. If you haven't seen this before, it's an awesome package that has literally everything that you need to build, and then they have components. So once you install this frame.js, you can directly use some of these components that is readily available to you. And then with that particular component, you can customize it as you want. Another one is a frame in 100 lines. I love to recommend this particular project because once you clone it, you can get started immediately. And you also see example of how to quickly, create a backend, how you can interact with the backend, and then how you can render frames on the front end. So feel free to check it out. And then we also have frog.fm. It's also kind of similar to what frame.js does, but then they have like different functionality ahead of each other, and then they have like things you can do differently. But the underlining concept you need to understand is that they pretty much allow you to write less code by just copying, like calling components or using components, other than trying to create like long list of meta tags depending on what you want to preview on the front end. And also they've done like quite a lot of abstraction that you just need to call the function after installing the package, and then you'll be able to interact with your frame or like build a frame that people can interact with and also do some sort of customization. And then finally, we have the Onchain kits, which is also a React component and a TypeScript utility that help you build your top tier Onchain app. But then they have components specific for frames that you can check out that is available to you for free, of course, just installing the package, and then you'll be able to interact and use some of these components that are available to you to build out your frames, to make frames transaction, to do all of this cool stuff from your application. So, and then we have the Webcast frame validator. This is a validator that helps you validate your frame before you go live. Like before you share it with the public. Go live is just like dropping a link and then it's live. People can interact with it. But then this frame validator allow you to it helps you validate your frame, make sure that you have all your images, your button setup. You can see all these green check marks. It allows you to do that. And then it also helps you, like, if you can paste in your own URL here and test your frame directly here. You'll be able to do that like for free. If you just check out Webcast frame validator online, you be redirected to this particular page, and then you can test your frames. But then, is that all? Of course, that's not all, because we talk about like the frame part, and then what you can do with frame and how you can do it, and how frame architecture works under the hood. Now, let's talk about multi-chain interaction, because by default, when you are building a frame, you are most likely thinking about just interacting with one blockchain, and then you're good to go, sending transaction, retrieving transaction, and doing stuff. But what if you want to do like multi-chain interaction? You want to talk to Base, you want to talk to Ethereum, you want to talk to Avalanche at the same time. How do you do this interaction directly from the frame? This is where multi-chain technology comes in. And what exactly is that technology? It is Axelar General Message Passing. What exactly is Axelar General Message Passing? It allows you to send, interact with different contracts across different chains in a decentralized manner. And then we have two functions that can allow you to do this. The first one is core contract. The second one is core contract token. So I'll explain what this means in a bit. So the first one is core contract, right? Core contract is just a function that you can call within your contract that you are interacting with, right? And then you can specify a few information about what you want to do. So I want to interact, for example, I want to send hello world to a builder. Maybe I'm on Ethereum right now. I want to send hello world to a builder on Base. Then what I can do is to just call this function, specify the person's destination chain, which is Base in this case, specify the person, the contract address, and then specify the payload. So payload here could be like a string, it could be an array, it could be, anything that you can, typically the types of, the data types that we have in Solidity, you can encode that particular, you can set that particular payload and then encode it. And then this other function here, which shows underscore execute, is the method that gets run automatically on the destination chain. And then this helps you decode like what the source chain is, the source address, and then the payload that is sent from the origin chain, that's source chain, to the destination chain. So if you have things like, say, for example, you want to do an airdrop, or like you want to build a bounty application, and then you want to reward like millions of people. And the thing is that you have these assets on Ethereum, but you want to reward people on Base, right? Everybody that's submitted their wallet address, they want to be rewarded on Base. You don't have to stress, you don't have to try doing conversion or stuff like that. All you just need to do is to set that particular assets and then send it from chain A to chain B. And then under this underscore execute method, run the function to like write it a method or a function to disburse the amount to all the wallet addresses that were submitted, right? So this is particularly for sending messages, which is pure messages without assets. For the example I gave about airdrop, this is what you need to do, because what is different from core contract with token and core contract is that this particular one allow you to specify asset and symbol. But the first one is just to embed like, data, embed strings or whatever type of data that you want to embed in the payload, and then send it to the destination chain. But this allow payload plus assets that you want to send, and also the amount that you want to send. So in that example that I gave, where you want to like do an airdrop to like millions of people, all you just need to do is to call this function here, and then on the destination chain, the underscore executes with token gets run automatically, and then inside this method, you can just specify inside this particular method, then you can specify what amount you want to share to all of these millions of addresses, and then who are the addresses. But then you can get the address direct from the payload, because that is from the source chain. And then you can split up the payment based on what you want to do. And you can write the entire logic inside this particular, method. And this will get run automatically whenever that message arrives at the destination chain. So, but before I proceed, let me pause here a little bit and see if you guys have any questions. Please feel free to unmute your mic and then ask your question. I'll wait for like a few seconds. If no questions, then I'll proceed.
Hey, let's check the chat also. Let's get the question coming in, guys.
So basically what we've covered so far, if you have like question or needs or clarification at this point, it's fine. If you don't yet, but it's fine. Feel free to like drop the question or like just call my attention and then I'll be happy to answer them. Okay, I think we are all good, right? There are no questions. Okay, so all right. Thank you very much. Please go ahead.
Okay, my name is Said from
Nice
Lagos.
to meet you, Said. Thank you for joining.
I would like to ask a question. So, thank you for the nice explanation so far. So, and I've been hearing a lot of languages like chain, token, NFTs, and the rest. So I would like to ask, when you say on-chain, my understanding of on-chain is probably when you do a transaction, the transaction is going to be effected immediately on probably Ethereum if we're on base. And I also learned that there's something called off-chain. So, and I learned that the difference is that probably for on-chain is much slower compared to off-chain, whereby there's probably some a processing that is not happening on the blockchain itself. So yeah, I would like to understand the difference and how it affects what we're doing here.
Yeah, thank you very much for the question. So yeah, we have on-chain, we have off-chain, right? But then it depends on what you're trying to do. There are some things that you might not be able to do off-chain, right? So for example, I want to send you, Said, I have 20 ETH and I want to send you like 2 ETH. That particular thing cannot happen off-chain. It has to be on-chain, where I collect your wallet address and then I send you that particular asset. And all of these things will happen on-chain. And then for the other parts where you mentioned like on-chain, being slow. So this is like something that is known for like, blockchain problem. But the good part is that we now have layer twos and then this championing this, layer two ecosystem, really focusing on how your transaction can be as fast as possible and also very, very cheap, right? So with Base today, there have been a lot of transactions. In fact, before joining this call, I was just building something with Base and I've been testing like thousands of times, like hundreds of times, right? Without any hiccups and no issues, right? It has been really fast and also, very, very cheap to interact with. So that problem seems like a very outdated like problem because we now have like solutions to all of this particular problem of, it's not slow, it's slow, it's expensive. We are gradually moving away from that phase because now we are seeing, different blockchain coming up and then tackling that particular problem of, yes, we need to have fast blockchain, we need to have cheap blockchain, and at the same time, we need to also not compromise, security. So which is what Base is doing really well. I hope that answers your question.
Yeah, it does. Thank you so much. Then is it correct for me to assume that off-chain transactions are mostly NFTs? Or?
So NFT is just one out of 1 million things blockchain can do, right? So NFT is part of, when you are sending NFT or you are minting an NFT, it's part of on-chain transaction. Creating an ERC20 token is also part of on-chain transaction. What again? Like there are a lot of things that you can do on-chain. Maybe saving the data, a transaction. For example, what I was talking about within sending message from one protocol to the other with Axela. What we are typically doing is that we are going through like from one chain and then we are sending it through the Axela network and then going to the other chain. So all of these things are something that happens on chain and it's seen as a transaction from one chain to the other. So there are a lot of things that can go on chain, not just, NFTs alone.
Thank you so much.
Yeah, you're welcome. So is there any other question for now? If there's no other question, then I can proceed. All right. So end-to-end flow of what I was trying to describe, where you get to send message from one protocol to the other, this is what it looks like. So I want to send message from source chain, Ethereum. I connect my wallet to this particular dApp. This dApp sends the transaction to the gateway. An event is emitted and then goes to the Axelar network. From the Axelar network, goes directly to the gateway of the destination chain. And then a proof call contract call is being called to validate that yes, this transaction has truly been confirmed on chain and everything is okay and it has been voted for successfully. And then you reach the receiving end where underscore execute function gets run automatically. And then the user receives whatever that is sent from the source chain to the destination chain. So moving on, we have the demo side of things. So I want you guys to do something. Can you maybe screenshot this or like take a picture of this if you have like the big screen in front of you of this particular QR code? It's going to take you to a particular project that we are going to look at right now, and a project that you can fork, you can clone on your own to learn from or like to use to build your own application. And then basically what we'll be doing is if you go to this URL, scan this QR code, it takes you to the URL. You can either create, of course, you no longer need to create a new Next.js project if you scan this URL. You just need to clone it, install the packages, and then go through what you currently have. But then if you're doing this from scratch, then we need to like create a new Next.js project, install the packages, build the frame page, build the backend, write and deploy the contract, and then interact with the contract on Base, and also receive the message on Optimism as shown in this example. So let me quickly test. Let me show you what the end-to-end looks like here. 1 second. Yes, so I want to show you. So if you go to that particular repo, this is what you are going to see. It's called GMP frame. This is what you are going to see, the Next.js application. But then let me show you one example of what the end result of what that particular project looks like. So we have this beautiful frame. I'm using the frame validator here in this case. So we have this beautiful frame where the button here is saying, GMStar. Let me zoom in into the so you guys can see. Yeah, so the button here is saying GMStar, but it could be anything. I click on this button, it takes me to another frame where you can see that everything is being validated here, correctly. And then in this frame, I can see saying I should type in my message or like send like type in the message and send the message and send that particular message or read data from Optimism, because this particular example send messages from Base to Optimism. So that is why we have this other option that allows you to read the data that was already sent to Optimism. So before trying to send a new message, let me click on read data on Optimism. And then what it's doing under the hood is that it's reading the data on chain and then returning the result for me. So you can see here we have message from Optimism and the message is what? Hello world, right? So let me go back and then refresh this page again. Sorry, refresh this screen and then click on GMSR. It takes me to this application and then I can just say hello Onchain. Yeah, Onchain summer. So because I'm typing this message, what I'm basically doing here, if I click on send, this is not going to interact with just on blockchain. What this is going to do is going to call that method I talked about during the presentation on the base contract that I already deployed. And then it will send that particular message from base through Axelar to Optimism. So if I click on send message, I should be able to sign this particular message on chain from here. Okay, it says I don't have enough gas. So I think I can quickly find that. Oh yeah, I think I'm connected to the wrong network. Let me try and switch my network to base Sepolia. 1 second. Yeah, so, oh yeah, I think I'm on base Sepolia. I'm not sure why it's not showing. Base. Oh yeah, that's true. This is actually configured for mainnet, so I can't see. Let me do something really quick. Okay, let me just connect. Let me connect that. wish I can just change from there instead. All right, cool. MetaMask. Yeah, let me connect MetaMask and show you what I'm talking about. I built that particular frame to use mainnets. That's why it's showing that. So now I have MetaMask. I can just copy this message so we don't have to type. And then let me confirm what network I'm currently connected to. So is that this? Yeah. I need to connect to mainnet instead. 1 second. Yeah, so this. Yeah, this. Yeah, so I'm connected to this now. Is it this account? Oh, that's the wrong account. I don't have an asset on that account. Yeah, so I have this account now. I can click on retry. Send again. Wait, let me just refresh this. So the good thing about this is that when you use this, you can, test things out. If it doesn't work, go back to your Visual Studio Code and then try again. And then you'll be able to, still showing not enough font. I don't know why. Oh, sorry, I just switched. I didn't connect this account. All right, see now, you can see my screen. So now we have what continue in wallet. So I can click continue, and then I'll be able to sign this transaction. This is actually happening on mainnet, but of course you can do on testnet, right? But this particular frame, I did it. So after that, you can see it shows like transaction set, and I click on continue. I can click on this to check my transaction on chain, and it's going to redirect. I can decide not to click on it, right? You get not to take me out of the Webcast clients that I'm currently using, but I'm clicking on it so that I can show you all what it looks like. So this is what the system looks like on the Axelar side of things, where we send message from the source chain. It shows that the source chain is based, the destination is optimism. We have the sender, some other information that you can check on it. So it takes some time to finalize on the source chain. And then once it's finalized, it's going to approve and execute, which means that we'll be able to receive a message from source chain to destination chain. So while this is ongoing, and to confirm that later, we can come back here and then read data on optimism. We should see hello Onchain summer. So now I want to show you guys one thing before I proceed. Right. Let's go to our Visual Studio Code. So when you clone that particular project, I believe you guys can see my screen. Let me confirm once again. Can you all see my screen? Like, is it clear enough?
Yes.
All right. Thank you very much. Yeah, thank you. So now I have this. Let me zoom in so you can see even better. All right. So I close this. So if you close this, if you clone this particular repository, this is what you are going to see. This is what the project looks like, an Aperta project, Aperta, next year's project, right? And then you click on publish, you find some assets, which is images, and then you click on the app. So if you go under the app directly, we have the contract, and then we have the API. So remember, I was saying that we want to interact, multi-chain, right? We want to send from one chain to the other. That means we need to have a smart contract that we are interacting with under the hood, right? In this contract, I only have the ABI here, where I already specified it. But let's take a look at what the contract looks like, and then we'll come back to the code. So this is what the contract looks like. Let me zoom in. So this is particularly for multi-chain interaction. So let's say, for example, you are not doing multi-chain interaction, right? You just want to mint NFT or you just want to do something else, then it means that you'll be interacting with that particular contract. So all you need to now certify on the front end is just the ABI for the interaction, and you'll be good to go. So this is a simple send message contract that allows us to send message from one protocol to the other. And then we are importing a few things here. The first one is the Axelar executable that allows us to call the function that we want to call on the Axelar network. And then the gateway itself, which is the gateway deployed for that particular contract. This is a gateway that is already deployed for you, so you don't have to worry. You just need to interact with the interface directly. You can see we are importing the interface here. And then we have the gas service. So you might wonder, like, what exactly is the gas service? One interesting thing about blockchain is that you have to always pay gas, right? But then if I'm interacting with Base, I just need to pay gas once and then interact with Base, and that's it. But in a case where I want to interact with, Optimism from Base, how do I handle gas service? Like, how do I pay gas? And remember that Axela network is proof of stake network on its own that help you facilitate this cross-chain communication. That means I need to pay gas on Base, I need to pay gas on Axela, and then I need to pay gas on Optimism. That's 3 different gases that I need to pay for the transaction to be successful end-to-end. But then we reach this gas service that allow you to just pay once, and then we'll take care of the rest for you. We'll settle like what the gas payment will look like on the Axela network and also the Optimism, network. So, which is why we are importing the interface here that we can just call the gas paid function. So we declare a very simple contract here that allows us to send message. Let me see if I can hide these things. Noise. Yes. Sorry, hide floating control. Yeah. So now, in this simple contract, if you're already familiar with, Solidity, this is pretty straightforward, right? It just contains like 2 methods. And then the first thing we are doing is that we are, we are creating some variables to hold our value, the message that we want to send, the source chain address, the source chain name, and then the source chain address, and then also the gas service. So we created a variable for our gas service, which we are extending the interface, right? We are using the interface to create this particular one. And then in the constructor, we specify the gateway and the gas receiver. So gateway and gas receiver these are addresses particularly deployed for a contract that you want to deploy on. So for example, on Base, if you go to our documentation, you go to docs.axela.dev. Let me just go from the beginning. If you go to docs.axela.dev, you see this, you click on developer, you scroll down here, you see testnets. When you click on this testnet, you scroll down, you see that we have like a lot of, all info on Avalanche, Binance, all the chains that we support. So if you scroll down to Base, because we want to deploy that particular contract, let's say it's Base Sepolia, you can see we have the gateway contract, and then we have the gas service contract that we need to set in the constructor. So this is where you can get it from. And then if you go back to Remit, you can specify that here in the constructor before you deploy the contract. And then what we are doing next is to assign that gas service to this variable that we created earlier on so that we can reuse it within the application and within the contract. And then we now have another method called set remote value. This is where we are actually sending the message. This is the function that does the message sending. And you can see something similar to what I showed during the presentation where you specify the destination chain, the address and the value that we want to send. We create the payable function. And then the first thing we are doing here in line 35 is that we are ensuring that a gas is paid so that our transaction does not get stopped. So once the gas is paid and everything is fine, we can proceed to like encode our value. In this case, we are sending just a string. It could be anything, you encode it. And then on the gas service, we are calling the pay native gas to pay for this particular call. And then we are passing the value that we got that was paid when this function was called, right? We specify this address, which is this address, like where the gas is initiated from, destination chain, destination address, which these are details that are already available, the payload that we encoded, and the message.receiver. So you might be wondering what exactly is that message.receiver. This is the person that received the gas that was refunded. So for example, I want to send from Base to Optimism, right? And I randomly just entered like 0.1 ETH, and then it took like 0.00001 ETH for that transaction to go through. That means you have like a lot left. So that particular leftover is what will be refunded to any address that was specified here. So in this case, I'm specifying the sender, like the person that called this particular function, to just receive the remaining balance, right, back to his or her wallet. And then finally, I'm calling the gateway contract, and then I'm specifying the destination chain, destination address, and the payload. So this is where I'm specifying like the core contract, right, that we mentioned during the presentation, where we just call this and specify what we want to send, the message, destination address, and destination chain. And that's all we need in this function to send our message. And then the last function here, which is a function that gets called automatically whenever you send something from the source chain and it gets received on the destination chain, this function gets triggered. And you can see we are just doing something very simple. We are decoding the payload and then assigning it to value so that we can be able to save it here and then call it on our front end, right? And then we're also saving the source chain just to be sure that we can know where the call is coming from because of hacks or attacks. In case the message is coming from unauthorized source, you can tell from the source chain and destination chain. If this is not where you triggered the message for, then you can flag it. But in most cases, this is always true because end to end, you can be able to tell which source chain and also which source address. Right. So this is the entire contract that you need. And this is what I'm using the ABI under the hood here. Here, I just copied the ABI here. You already have like all the function that we can interact with, which is something that we can now directly interact with in our frames. Right. So if you open this, you see that I just have like 4 directories. The first one is the home page. And this home page, if you open the home page, you see that we have this Onchain kits components that we imported, like this get frame HTML response that we are using to render our page. So in this case, I have type in your message here, and then I have 2 buttons. First one is sending message. The second one is reading message. And you can, if you take a look at this, like the actions are quite different, right? This action is for transaction, and then this action is for posting. I just want to post to a backend and then read the data. But then this particular one is for sending a transaction. And then I'm setting the target here and then the post URL. So for example, when you want to send a message and you click on send message, the system hits this target. And then whenever that send message is completed, it now falls back to something. Because now I signed the transaction. If you see the other time, when I signed this transaction, it falls back to my application. That screen that is going to fall back to is the post URL that you need to specify here. So you can see how you can customize your own frame yourself on, do this, and then after this is done, fall back to this URL, right? And then we also have the other one for reading on optimism, because this is just reading, right? We don't need to fall back anything. We just want to read content, and then it's just going to return this particular frame for us, right? And then I have the image, I have the post URL. You can find everything on the Onchain Kits documentation. So let me quickly show you what that looks like. I think I have it open somewhere. Okay, no. So let me just open that quickly. So if you check Onchain Kits, I think it does XYZ, if I'm correct. Yeah. So if you check Onchain Kits, you find it here. So you find literally all the components that you need. Go under utility. Let me see. There's a particular section for frames. In fact, you can just search directly. Yeah, so there's a section for frames, so you can check the frame directory. And then, this is the frame directory I was looking for. So you can see the frame metadata. You can see some of these methods available to you and how you can do like things like get HTML response, all of these things that I was able to use to build. I found like everything on this documentation, and then you can just continue building on your own. So let's go back to the code base. So on the code base, now this is what the homepage looks like. And then now let's check what, sending message looks like. So sending message, we have this here, where we send message. So whenever you click on that particular send message method, this is what it's going to hit. This is like the backend that the frame server or like that, the client is hitting to get a response from. And then what am I doing here? Very simple. I have my contract deployed on base and optimism, and then I'm just validating the request that is coming from the frame. And then after that, I am invoking this particular encode function data and specifying the API that I added in the directory, and then calling this method set remote value. If you remember that this particular method is on our contract, and then I'm passing the destination chain optimism, the contract address, and then the input text that the user entered, right? And then I'm specifying the base, the chain ID, the method to send this particular transaction, the base contract, and then the gas. So you can see how cheap it is, right? Very, very cheap. I think it's even cheaper than this. I just added this gas fee because I'm sure that even if I have leftovers, Axela is going to return the remaining one to my address, right? And that's all you need to create a backend for your frame. So in case you have like custom action that you want to do, you can add it here, and then the system is going to return it. So, but then something to note is that once this process has gotten to like line 36 and it has returned the transaction data, it is going to utilize the fallback. So the fallback URL route here is send message success, right? So after the message has been successful, I want it to fall back to a particular page for the user. So now it's going to fall back to this page where I can view the transaction, I can read data on optimism, right? So which is what we saw earlier on when I was trying to test this particular frame, right? This is the fallback page. I can view the transaction of what I just did right now, or I can read data from optimism, right? So this is the tool. You can see how easy. You can see you didn't even see anything like meta tags. This is why this guy exists, right? Because under the hood, you already built the component in such a way that it's creating the tags for you. And all you just need to do is to call this function. So if I click to check what this function is right now, it's going to take me here. So you can see inside the function types that I'm currently using, you can see what each image source, OG image, HTML, all of these things, you can see they are actually just creating a meta tags for you. So instead of writing this every time, just calling this particular function and then passing the parameter would automatically write all of this for you. How cool is that? That's how you can manage your time efficiently and then build frames like a pro without having to like repeat yourself, like doing some repetitive stuff and all of that. So let me go back to the route, and then that's it for reading message, and then for sending message and the fallback image, or like the fallback frame that the system is going to fall back to after a message is successful. So the last one here is the read message, and this is very simple because it's similar to sending message, but in this case, I'm just reading message, and then I can pass the fallback directly here. You can see when I click on read message, what am I doing here? I'm just creating a client and then reading that particular message that was sent from base to optimism. But then here you can see I'm reading directly from the optimism contract, which is the destination chain, and then I'm passing the value here, and then I'm displaying that particular value on the button. When we started when we wanted to test that particular frame, remember that I read from optimism, and then it redirected me back to this page where it's showing message from optimism, hello world, right? This is where we are displaying the frame. So just calling it this way, you can render your frame with ease, right? And that's like what the project is all about. You can see how easy it is for you to build frame. There are already things that you're familiar with. There are React components, it's Next.js. All you just need to know is what are the parameters you need to pass, what are the parameters the frame is expecting, and then how you want to go about it. So that's like the end-to-end process for what the project contains at this point. I'll pause here again to see if there's any question before I proceed. Yeah, any question? Yeah.
Yeah, let's take a few seconds to like make it engaging.
Yeah, exactly.
Yeah.
Exactly. So in case maybe you don't have any question, you just want to try things out yourself, it's fine. You can try it out. You can always reach out to me on Aladdin Soft, like anywhere. Just ping me, let me know. Maybe you're having an issue, I'll be happy to help. Or on the Ethereum Nigeria group, I'm also there. You can ping me.
We'll be adding Idris on the channel, the Hackers channel, so you can easily reach out to him there afterward.
Yeah, so in case you don't have any question for now. Also, feel free to check the repo. You can find all you need there so at least get started. And then let me go back to the presentation and round up for some time. So now, let me continue the slide. So now we have some frame hackathons that you can explore. One of the biggest is Onchain Summer. Like there is a lot to, to check out and also to benefit from. It's almost over, so you can still build something with frames. Just build something with frame and then participate in the hackathon. Choose the option for Farcaster and then watch and see what happens next. And another one from the Arbitrum, Farcaster frame Buildathon that is also happening in batches. You can check it out. And also, if you want to see like all the frames that is happening so far beyond the hackathon, beyond Onchain Summer, the one that's currently happening within Onchain Summer, you can just go to bankanster.xyz/tags, and then equals to tags dash frames. And it is to show you all the lists of hackathons or like buildathons that is currently happening peculiar to building a Farcaster frame. And then you can just choose your shots directly from there. Trust me, building frame is very easy. You just need to understand what exactly is that thing that you want to do. Once you figure it out, then you can check out the documentation, check out the repository, or check out the examples the tools that I shared earlier on, and you can start building on your own. If you get stuck, check out my implementation. You can also, learn from it and move on. So to move on, we have the support. So if it is not frame related question, if it's Axela related question, you can just Google Axela support, and then you see this repository, create an issue there. We get notification almost immediately, and then we'll help you with any of your questions that you have. And then we also have the Axela example, which is a repository that allow you to, to see some of the examples that you can play around with. So if you want to get started, we have a bunch of examples that can allow you to get started. And also locally, you can build your own. You don't need to test on test names. You can set up this particular example locally and then test question interaction locally for free. Like you don't need to start looking for faucet or things like that. You can do all of these things locally on your own. But one last thing before I end this slide is there's also this happening that I just want to quickly talk about tomorrow. So in case you have like time by 4 p.m. Nigerian time, if you're in Nigeria, it's happening, building Farcaster frame for bridging ERC20 token with ITS. This is another one different from what I showcased just now, where you could just build like a frame that allow you to send message. But in this case, you can build a frame that allow you to reach your ERC20 token directly from Farcaster client. It contains like a lot of robust, implementation under the hood. But the point is that you are able to do it end to end. I'm just going to drop this in the chat and maybe we'll share with the organizers later. It's happening for tomorrow if you can join live. Yes, and then back to the presentation. Yeah, I think it's over. So thank you all for joining. I encourage you guys to please let me scan this QR code right now, or like take a screenshot and then use Google Lens or something to like get the QR code and go to this particular survey. It takes less than 1 minute to fill in. Let me know what you feel about this, entire presentation, the workshop, how this has been able to like make you understand what frames are, or how these have been beneficial to you, or how best you would recommend this type of workshop to anybody anywhere in the world. I'll be happy to get all of those feedback and improve on it in my next presentation. Thank you so much for having me. I really appreciate it.
That was superb. Thank you so much, Idris, for doing justice to that and then making yourself available for the next few days. So, guys, yeah, we'll continue this conversation on WhatsApp as well. So at this point, I'm going to invite Tuluwani to take over. He leads the Web3 Unilag. Yeah, over to you guys.
All right,
Yes,
guys.
Toluwani there. Okay.
Yeah, I am. Yeah, sorry. Hi, guys. Welcome to day 2. Thank you, Idris, for this nice session. So Zach isn't here. So all we're doing is it will be a very brief session where we'll try to communicate what's. I understand that some of us have splitted into teams, so we need each team to come in and give kind of an overview of what you are planning to work on, what you are building, what is meant to solve, and introduce yourself, your team members, and so that we can be able to identify members who haven't gotten a team. So is Dimitri or is Dimitri's representative here? Dimitri or Dimitri's representative? Okay. How about Morenike? Is Morenike here? Mm, okay. Still no reply. Um, okay, let's just do this. Let me open the floor to any solutions based off on the discussions that we've been having for the past 2 days now. Let's open the floor to any suggestions as to what we can build that will help us gain proper recognition in this Buildathon. Any ideas, we are open to any. While just to inform you that there will be a form this evening or late tomorrow morning, so that you can send in your area of specialization, whether you are UI UX or project manager or a dev, front end, back end, smart contract developer, so that we can fix you into appropriate teams and so that we can all start building. However, before then, we are open to getting ideas as to what you would like to build or what solutions you would like to create for in during the course of this base build. So it's kind of like an open floor session now. If you want to bring forward your solution.
So one quick question, please. It's going to be maybe a little technical question regarding I was looking at Ethereum and Base. So I would like to look at how what are the improvements the Base chain has actually added on Ethereum to make it probably fast or more efficient or whatever it is.
Yes. You just asked a question. Say the right?
Yes, I this.
Okay. Your question is, what is base bringing to the table, right?
Yes. On top of Ethereum.
Not about Ethereum. Okay. First, you need to know that base and Ethereum layer 2 solutions and developed by Coinbase. You know that, right?
Yeah.
So there are key improvements they brought to the network. One is scalability, two, security, three, the developer experience. Just as you heard what Idris shared. Before joining this call, he was actually building some stuff, and he kind of expressed how a whole lot has been improved. The user experience too is another, the fourth one. The economic efficiency. So that's where we talk about the gas reduction. So you can build, test, iterate, and stuff like that without scaring like huge gas fee and stuff like that. So environmental impact, the adoption, and the ecosystem growth. So a lot of builders are already building on the networks. So when I say scalability, I'm looking at increased transaction throughput. You know that, right? It has reduced congestion on the Ethereum network. You agree with me, right?
Yes, yes.
So these are significantly improved the transaction throughput by processing transactions off chain and then batching them together, then before submitting them to the Ethereum mainnet. So that's a plus. Initially, I remember after the DEF CON experience 2019, we came back and started the Ethereum Nigerian community. And then, yeah, I actually did a bootcamp with the consensus. And then some of the experience the challenge we had was like the gas, you know. So it was really, it didn't really encourage our community growth. Like people were like, using exploring other platforms. So when you talk about security as well, Base has leveraged Ethereum actually have a robust security model. So Base also has really ensured that security and integrity of transaction process on Base are maintained. So that's like, a plus. So optimistic rollup. So Base is actually using the optimistic rollups too. So you've been hearing optimism and stuff like that. So does allow fast transaction. Let me not bug. In terms of developer experience, if you're hacking now, you understand what I'm saying. It's fully just as what Acela is another, but you can see the compatibility and Base syncing with Base and stuff like that. Recently, we just finished the interoperability, and Base is actually driving one of the goal of the super chain. When you talk about the super chain, you're looking at the leads, the Base, many of them. All right.
Yeah, thank you. Sorry, I'm asking too many questions, but probably. So yeah, let me ask more questions. So yeah, I read that so any chain that is built up of the main chain like the Bitcoin and the Ethereum, they are mostly they run mostly as off chain, or call it L2. Then they come back and probably they might have some disadvantages, which according to you now, you said Base has been able to improve on these setbacks when you're having an on-chain, because you don't have the transaction happening directly on the chain, in order to improve speed and efficiency and the scalability, like you said. So so I'm looking at a situation whereby I can use a blockchain for improving some cybersecurity stuff. For example, in IoT, the IoT devices, they are very poor in terms of security. They are very vulnerable. So I'm looking at a situation whereby I will use blockchain to further secure the data that is captured using IoT networks, something like that. So in that case, probably the on-chain might not be an issue for me. I don't probably need to be on-chain. I'm only interested in securing data end-to-end. So maybe probably something like Base, which runs off-chain, then come back and merge the information, is probably a good option for me. So yeah, that's the reason I'm asking, so that I can know all these differences.
Awesome. Yeah, that's interesting. So I hope you're hacking.
Yeah.
Yeah, so Luan, it's over to you.
Sorry about that. Okay, so you mentioned the difference between Ethereum and Base network. I think one of the key hacks that Base has done is gas. We all know how Ethereum is always valuable because of the presence of integration, and Base has been able to hack transaction fees and making it way lesser. So I think that is one of the reasons why this is here and here to stay. But we can also look at other ways we can make different integrations for Base. If you have dApps idea, different payment platforms and all of that. Yeah. So there are different solutions that we can bring to Base. We were talking about the bots yesterday. However, we need to get into get into the nitty-gritty and get into hacking. So we are kind of past the ideation phase. We are getting started with the building phase majorly, which is why I said forms will be sent out, and then so we can start working. I'm really sorry, Zach is kind of meant to lead this call, but he can't make it today, so I just have to step in, yeah, for him today. So I think that is all from my end. Further information will definitely be communicated to you very soon in the group chat between and tomorrow morning. Yeah. Thank you guys. I'll see you later. Over to you.
All right, guys. It's been an exciting moment having Idris Tulwani and Said on the show. I want to hear Abayoni was on the show yesterday. I cannot hear his voice today. No problem. Emmanuel, let's feel you. I can see laughter. I can see Daniel. AMD, what's up? So we were wrapping up this session. Thanks for your time. We shared the Telegram and the WhatsApp group, so just join so that you can get more information. Yeah, we're happy to have Idris on board. He will also help in terms of mentorship, and you want to know a little bit about some great stuff. So please feel free to follow us on X at Ethereum Nigeria. Follow us on X at Web3 Unilag. Follow us on X at Web3 Africa. What other communities here? Please just let us know. You can drop it on the group too. Yeah, so let's make this an incredible moment. So we just have a few days. So then we'll see you same time, 7 p.m. tomorrow. Is there any other question? Our friends on YouTube, we're happy you guys are tuning in. Yeah, so join us on the hacks. So there's no question. So on behalf of the team, this event has been made successful with the collaboration of Web3 Unilag guys and the Base communities across Nigeria. And it has been sponsored by Base and powered by the Ethereum Nigerian community. We're also happy to also have great technical guys for on the charts, and we're making our time to support you guys. We'll be sharing some more information on those WhatsApp. Hopefully from tomorrow we'll be getting more engagement as well. Our friends from Kaduna, we hail you guys. Port Harcourt, we hail you guys. Anambra, Abuja, Edo State, salute Ibadan as well. So friends in Unilag, thank you. So then, have fun. Stay safe.